Solving systems of equations by substitution. We'll be looking at 3 DeltaMath problems, level 1, 2, and 3. We'll start with level 1. In this problem, we're given a system of equations, 2 linear functions, y equals 10x and y equals negative 3x plus 39. We can see that these two functions are written in slope-intercept form. They have different slopes, so there will be one solution. But because they're both written in terms of y, we can set the expression for the first function equal to the expression for the second function. So we can write an equation in terms of x. 10x equals negative 3x plus 39. Now let's add 3x to both sides and rewrite the equation. Let's combine like terms. 10x plus 3x is 13x equals 39. And so when we divide both sides by 13, we get that x equals 3. So that is the x-coordinate of the solution. If I were to graph these two lines, they would intersect at a point, and the x-coordinate of that point is 3. Now to get the y-coordinate of that point, I can substitute this value of x into either equation. I'll pick the easier equation, y equals 10x. So we'll substitute x for 3. And we know that the y value of the solution is now 30. And so the solution that I would type into the DeltaMath box would be 3, 30. I would submit that answer, and that would be correct. So level 1 problems, when both equations are written in terms of y, and you don't have access to graph paper, you can set the two expressions equal and solve for x, substitute the value into one of the equations to solve for y. Now level 2 is a little bit more challenging. One of the equations will be given. It will either say some x equals something or y equals something. I want you to look at the top equation here in terms of x. X is equal to negative y. So what we're going to do is we're going to substitute that expression, negative y, in place of x in the second equation. And we're going to write negative 7 times negative y minus 5y equals negative 20. Notice we have substituted x for the value that it was given, negative y. Now we're going to multiply, and negative times a negative is positive 7y minus 5y equals negative 20. Let's combine our like terms. And now we're going to divide both sides by 2. And we know the y value of the solution is negative 10. To get the x value of the solution, you want to pick the equation that looks like it would be easier. And that would definitely be the top equation. I'm going to write it as x equals negative y. X equals the opposite of y is how I'm going to interpret this. So the opposite of negative 10 is 10. That is the x-coordinate of my solution. So the solution to this system of equations is 10, negative 10. And just to review, for level 2 of DeltaMath, you're going to be looking in one of the two equations as x equals something or y equals something. And that's what we use to substitute into the second equation. So we'll go on to level 3 now. And in level 3, we do have one equation in terms of x, right? X equals this expression. So x equals 3y plus 3. Now that expression, 3y plus 3, we're going to substitute in place of x in the second equation. And we're just going to write our new equation carefully. Instead of x, we're going to write 3y plus 3 minus 10y equals negative 25. Now notice we have an equation written in terms of y, so we do not need the parentheses in this case. We can combine like terms. Let's subtract 3 from both sides. And let's divide both sides of the equation now by negative 7, giving us y equals 4. So that is the y coordinate of our solution. Now what we do is we take that y value and we substitute it into one of the two equations to solve for x. And you want to ask yourself the question, which equation looks like it would be the most efficient to use? Well, of course, that would be the top equation, right? And we'll write x equals 3 times 4 plus 3. Use order of operations. 12 plus 3 is 15. That is the x coordinate of my solution. So hopefully this little tutorial will help you solve some systems of equations by substitution on DeltaMath.